Now, before we go into the procedure of how to perform ANOVA, let's understand certain terminologies. The first terminology that you need to know is the grand mean. Grand mean is nothing but, in this case, the mean of the entire tomato size column. The entire column, the mean of it is the grand mean. Sample means is for each group that we have. In this case, we have three different groups. For each group, there is one sample mean. So that would transform as the mean of these variables or these samples, this samples, and these samples. Three different sample means we have. Between group variability is given by this particular formula on the right. It is also called as mean squared between in ANOVA terminologies. What that translates as is the sum of squares between the group divided by the degree of freedom between the groups. We will go into the computations of SSB and DFB when we look at the hand computations, but understand that MSB, that is mean squared between, refers to the between group variability that we saw in the previous image. In case 1, the between group variability is quite high, whereas in case 2, the within group variability is quite high because the points are more dispersed or more spread out compared to case 1. We will look at this step by step in more detail. Now let's understand the procedure to perform ANOVA. As always, the very first step is to establish the null and the alternate hypothesis. The next step is to compute the formulas and fill up the ANOVA table. After you fill up the ANOVA table, we will compute the F statistic, then compare that F statistic to the F critical value that you look up from the F distribution table. Alternately, you can compute the p-value directly, and if the p-value is less than the alpha level is typically equals to 0.05. If it is less than the alpha, then we reject the null hypothesis. Now, what is this ANOVA table? How does it look like? We will get to the ANOVA table, but first let's formulate the null and the alternate hypothesis. The null hypothesis states the means of all the groups or the populations are the same. The alternate is the opposite, that is, at least one of the means is different from the rest of the groups. So that is the alternate. Now, how this translates for us in terms of these pictures between case 1 and case 2 is, in case 1, for H1 to be true, the between group variability has to be greater than the within group variability. So for H1 to be true, means of at least one group has to be very different from the rest. For that to be true, the between groups, that is between group A and B, the variability should be quite high. If that is higher than the variability within either of these groups put together, if that is the case, then we reject the null hypothesis and H1 will be true. The opposite is true for case 2.